Hello, Chem 1A. This is Chapter 2, Lecture Video 1. In this lecture video, we're going to be talking about atoms. So, atoms are made up of subatomic particles. Atoms are the smallest unit of an element, and they're made up of mostly empty space. Now, most of an atom ends up being just this empty space here. Most of the mass of the atom actually exists right there in the nucleus. And the nucleus contains both the protons and neutrons in the atom. And protons and neutrons are subatomic particles. These white specks that we see all around the nucleus are the electrons. And they are the third subatomic particle that we'll talk about in this chapter. So protons and neutrons, they hang out in the nucleus of the atom. And the electrons, they orbit the nucleus. Atoms are extremely small. It's hard to even have a reference for how tiny an atom is because we have nothing to compare it to. So here's an example. 1 teaspoon of water has 3 times as many atoms as the Atlantic Ocean's volume in the units of teaspoons, which I'm sure you can think of how big that would be because you've all seen a teaspoon before. So even that size of the Atlantic Ocean, if we measured that in teaspoons, 3 times that number is how many atoms are present in just one of those teaspoons, as far as atoms go. So very, very tiny, lots of them even in a small place. And atoms are made up of primarily three subatomic particles. There are more, but we're just not going to talk about them in this chapter or really this class. So the primary 3 subatomic particles are protons, electrons, and neutrons. And I need you to know a couple things about each of these subatomic particles. I need you to know that a proton has a positive charge, has a mass that is significantly larger than an electron, but similar to a neutron. As we can kind of see here, both protons and neutrons have about the same mass. Now in grams, this is a very, very small number, right? 10 to the negative 24 for our scientific notation. However, we usually use atomic mass units to reference mass of individual atoms, and that is usually symbolized by either a U, like we see here, or AMU is the symbol for atomic mass units. And this is just another mass unit as opposed to a gram that puts the mass on a magnitude that's more easy to deal with, right? So we see that a proton has an atomic mass unit of about 1. Electrons have a negative charge, and you should know that. You should know that electrons have barely any mass when compared to protons or electrons. Again, I don't really need you to know their exact masses. You should know that protons are around an atomic mass unit of 1, and electrons have barely any mass at all. You should know that electrons are negatively charged and protons are positively charged. And finally, for neutrons, you should know they have no charge, and that they have approximately the same mass as a proton and around an atomic mass unit of 1. Now, when we think about an atomic structure of the atom, you should also know that the protons and neutrons are in the nucleus, where the electrons also orbit that nucleus. When an atom is neutral, this means that it has to have equal protons and electrons in its subatomic makeup, right? So every proton is positively 1 charged, every electron is positively negatively 1 charged. So if the whole overall atom is neutral, then we have to have equal numbers of these two so they cancel each other out. The atomic mass of any atom is approximately equal to the sum of the protons and neutrons in its nucleus. We usually call this number the mass number. And the mass number is simply how many neutrons plus protons you have in the nucleus of the atom. Electrons have such a tiny, tiny mass when compared to protons and neutrons that we generally ignore them when determining mass. This brings us to the atomic symbol. Atomic symbols are used to represent elements with they're a subatomic makeup, right? So generally an atomic symbol looks something like this, with three components to it, an A, Z, and X. X is the elemental symbol, what we can find on the periodic table. Z and A are the atomic number and mass number, respectively. So the mass number, again, is the number of protons plus neutrons in that nucleus, and Z is the atomic number, and the atomic number is equal to the number of protons in the nucleus. We can find the atomic number in the periodic table symbol, or square, for that element. We leave out Z sometimes because if we know the element symbol, then we know its atomic number because they are always going to be the same for the same element. For instance, here's a periodic table square for aluminum. And we have the elemental symbol, we have the atomic number, and we have the atomic mass. Now the atomic mass we'll talk about more in a later lecture video. It is not to be confused with the mass number. Mass number and atomic mass are not the same thing. In order to know the mass number, we need to typically be given that information or told how many neutrons are present in that atom's nucleus. All right, so if you have any questions, as always, please email me or come to my office hours.